You can define your own graph like this, so it requires nodes and edges. So let's write path. It requires three parameters. So it requires graph, and it requires source, and it requires target. So actually I'm going to use a helper function. So I need to let keywords path helper JAV, and this one will be recursive function. So if the first case, if A equals to B, which means we don't have to traverse through the graph, it just simply returns empty list. Or it should return, it should call path helper function, and path helper requires for my answer it requires 5 arguments, which is first one is visited, and then the second one will be current node or current path. So let's say visited will be initially empty, and current will be the first one, the source one. Okay, so let's start from path helper function. So if the basic algorithm is we're going to move through the graph. So if we start from A, then we move to B and find the neighbor of B. So here's the neighbor of B. So we start from B and move to C and find neighbor of C. So we have found this one and this one. But the reason why we need visited list is we don't want to make a loop in a graph. So we don't want to make circuit before we find the proper path. So we don't want to go back to A in this case. We want to go to D. So that's why we need visited. So if A equals to B, which means we have found a proper way to traverse through the graph, then we return the current. We just simply return currents because this will be the path. So let me change the path. Change a variable name. So, or we need to traverse through the graph, right? So I'm going to use some let keywords. So we first of all we need to find neighbors of the source node. So if the source node is C, then we need to find the neighbor of C, which is A, B, and C, A, B, and D, because C is all connected to A, B, and D. So we need a list called neighbors that contains all neighbors of the source node. So I know it's a bit confusing if we use the same variable from node, but as the question said we have to use A and B, I'm going to just use A and B. But you can think of this A as source and this B as target. So first of all, there's 2 cases. I'm going to use list higher functions, but if you don't want to, then you can define your own function. So there's 2 cases. First of all, if the first one equals to the target as the actually source they were looking for, or the second one of the tuple can be the source that we are looking for, and both of x and y should not be invisited because we don't want to make a circuit. So to check how if the element is in the list, we use list.mem. So if x is invisited or y is invisited, we don't want to proceed. So we don't want to use them, so we apply not keyword here. So what this function is doing is find if the node contains the source, which is A, and find if the other one, both of the tuple, is not in the visited list. So, as you know, list.filter requires 2 arguments, so we have just wrote the first one, and the second one, which is list, we're going to get edges of G, right? So we just simply use g.edges, as you know, in CC 114 or 214. Yeah, it's same as Java or Python. You just simply add dot and you access the property or attribute.